be giving us an overview of the project and the goals and its current status. Okay, Chris, you're there. Go ahead.
Hi, Megan.
Hi.
So yeah, I'm gonna go give everybody an overview of OpenMBE Flexo architecture, which is a good lead-in after seeing the SysML 2 ontology work that Megan did. I'm gonna go ahead and turn on my camera. Hello, everybody.
Oh.
And or should I not turn on my camera? Am I gigantic now on the screen? Oh, I think I am. All right. So, and I'm joined by my colleague Marie from our group as well. So I'll give you guys a brief overview of where Flexo is at and a little bit of background on what OpenMBE is if you've never heard of it before. And then Marie will do a demo of how we won't show the actual work that we're doing on MSR, but we'll show a representative example and she can answer some questions about how we're applying it to MSR. So let me go ahead and share screen. And yes, so good. Okay, that's cool. I can actually kind of see the camera with what I'm doing. So yeah, so OpenMBE is the open source project where the model management system is, and there have been several
Chris,
previous. Yeah.
Are you sharing your screen?
I thought it was. Let me try again.
See you, but not your screen.
Oh, hang on a second. I lost the Teams window completely. 1 second. Teams likes to disappear sometimes. There it is. All right, let's try this again. Share screen. Screen with audio or without. I guess I'll try it with. I guess that's for like videos and stuff. Okay. So, and you guys can
it's good.
Follow
we can
along
see it
with
now.
this. You can see it now. Good. Okay. And you guys can follow along with this if you want as well. It's at openmbe.org in the wiki. I'll paste the link into the chat. But yeah, so OpenMBE is the open source project where the model management system is maintained. JPL is a contributor and a founding member, along with Boeing and a few other organizations. And earlier versions of it were so the goal of the model management system in a nutshell is to provide an open source repository for systems modeling. And I'll kind of skip through a lot of the history, but feel free to reach out if you want to hear the full story. There's like a whole other hour presentation I can do on the history of it. But where we're at today with the Flexo architecture is building the model management system natively around two main communities of modelers. One is the ontology modeling community, and the other is the SysML version 2 modeling community, which drags with it the potential for a kernel modeling community, although I don't know if such a community actually exists yet, but I suppose it could. So the Flexo version of MMS is built around the concepts of having a model repository with similar functionality to Git, however, not using flat files, but actually using a model database, if you will. So the ability to create orgs, projects, the ability to do branching and diffing and merging, and having immutable version history on top of a graph database. And in the case of how the implementation is working today, the specifically uses semantic web. So this diagram shows the architectural layout of the technologies in play. And unfortunately, our third member, Doris, is out sick today. So any technical questions you'll have to save. Maybe hopefully she'll be back tomorrow if you guys are still around and have some follow-up questions. So I don't think Marie and I know that much of the details of the semantic web technology to properly address any of those questions. But if you look at the layers, the idea here is to have at layer 0, we have a triple store, which I think everybody here should be familiar with. But then on layer 1, we add access control versioning with branching, diffing, merging, and so forth. And magic properties, which is another semantic web thing that Doris would have to explain. And the platform goes up really to the key part of interest. The platform goes up to having the ability to create a microservice around a particular language concept. So like SysML2, GraphQL, OSLC, all of these services being driven by an implementation with an ontology for the language, being able to provide it as a service with those features. Coming in from the right, it's not really called out the same way, but the Sparkle interface to those layers also functions like a service, such that you can write, run Sparkle queries through that REST interface. It's not, as I understand it, it's not full Sparkle, but it is a significant enough subset that you can write meaningful queries. And then at layers 5 and 6, you can see where different client interactions can be written. And so Marie's going to show how the client interaction that we've written with Confluence works, such that you can reference elements in Confluence from the model that's in the repository. And probably a more recent milestone, I don't know if you mentioned, Magid, the demo that happened at OMG, but we were able to actually run, I think it's still up and running too, a test instance where using the SysML2 ontology and the open source SysML v2 web service, which is this kind of L-shaped piece here in the diagram, running on Flexo, folks were actually able to interact with that service, all open source, Apache 2. And to my knowledge, the only open source project dedicated to that kind of repository that unifies those two communities, and they did that back in March. So that was a kind of a big milestone. So yeah, any questions so far, or do you want to have Marie jump into the demo? All right, I think that's
Go for it.
you, Marie.
Okay, yeah, no problem. I will be stealing the screen from you. With the Flexo MMS architecture in mind, one of the use cases that we came across was people creating their systems and documents, their system design documents at various levels, and we wanted to leverage the interfaces and ability to get data out of Flexo and into a document format. And so our first example were for FDIDs, so the functional description and implementation documents. I'm missing. Anyways, it's those ones, formerly FDDs. And so we wanted to several instances where some requirements that were going to be talked about or used in SRL could be directly brought into these description documents. So here I'm going to show you the different ways that people are interacting with creating their documents. The intent, again, to be able to reference the data from the source of truth and bring it into the right context. So in this example, I'm just using kind of our training document. We have what we call the inline cross-reference example. And so when a user is editing a document, they can actually insert a reference to the data field of their choosing. For this, we used JAMA requirements for this example, but you can imagine whatever was in the MMS. Flexo MMS would be available for use. And so in this cross-reference example, I can just search by ID So I'm going to use the one that's in the example here. All I would do if I was editing my document is I could use the pound sign or hashtag and start adding it. You can see kind of in the middle of the page, I'm putting the ID that I know about, and it's going to look for the requirements that best matches the ID. And so I'm going to let's just grab this first one. And now it's going to ask, do I want the ID, like the API ID from JAMA, the requirement name, or the requirement text? Most often people have been using the requirement name for their reference, and then they can kind of keep going. They'll keep going on their reference. So I can click update, and you can see I didn't mess with the white space, but you can see that now I have this full reference to this requirement. If I'm interacting with the live document on the wiki or on the Confluence page, I can hover over it and it'll tell me a little bit more about it. It'll tell me all three attributes or all three fields: ID, requirement name, requirement text. It'll also tell me what version this is. We do give it the ability to update your requirements to the latest version, basically a pull every day. And so we put that configuration management in the hands of the authors so they have full control. And so I can see that this version of this requirement was from earlier, I guess last month. And then, so yeah, this one was referencing the name. You could see an ID in here. These are the three examples of how it would look within the document itself. And the hover, and then obviously it's used for inline for this specific use case. So you can see that people could actually put the data within the inline. Other thing to note is that if I hover over it, you can also see that the hyperlink goes directly to the JAMA reference. That is something that is also, oops, I'm not logged in, so, but let me just log in. You can see that if you wanted more information, it'll direct you to the live link of that requirement, and you can get more information that you need. So that was the most common feature that has been used for the FDID specifically, but there were a couple others that people wanted for their deliveries, for their initial release. And so we also have what we call the connected data table. We have three pre-configured queries that are available for, in this case, SRL specifically. And the idea is that if a user needed to put a table of requirement information, that they can go in and interact and query and publish that table directly in their document. So for example, in the requirement ID, you can see we have already configured it to have an ID, the name, and text, but you can also edit it. So a user would go in and go find more of the requirements that they need. I'm just going to use the drop down because I don't know a lot off the top of my head, but I can grab 3 more. This is my query type by API ID, and I can preview my results to see the other requirements that I'm interested in. And if that looks good, then I can go ahead and publish my table. And so this will allow users to make sure that they have all the requirement text that they need. And when they publish it, then it saves to the wiki version history, and therefore we can do some more configuration management, leveraging the Confluence features themselves. And then the other two I'll just briefly show was appendix subsystem requirements. There was a couple of functional areas and L4s that they wanted to use, and so we predefined this query and this configuration, and it's the same type of thing. You can edit, you can update some of the parameters that are important, and then publish the new tables. So we had a subsystem requirements table as well as a system requirements table. I believe the system one shows children. Yeah, this is the one at the bottom. So yeah, this all was used for the preliminary release of the SRL FDIDs. I'll say that obviously the preliminary release it's been a while, so they're going to go update and update their new FDIDs based on the new architecture. But this functionality is available to them right now. And then I think the last thing I'll note about this implementation is we are also leveraging the Scroll Docs plugin, or the document toolbox, and that's helping with our configuration management of these documents as a whole. There's a lot more ways you can manage like your initial release, your working documents. There's some branching and merging availability there. And so we're trying to leverage both the regular features of Confluence, the plugin features of Confluence, and then obviously the Nexus part, the most important part from our standards of being able to reference the data from their source of truth. I clicked the header as well, and you can imagine here, like I said, this example is just using requirements from JAMA, but you could have other data types in your configuration of your document once you set those up. Any questions about the functionality or anything I missed, Chris?
No, I think you covered it. That was good overview. I think now that we have the SysML2 ontology, our next plan is now for things that we want to create as a system model directly. We'll be able to use that and reference those items directly. And I think our first step on that roadmap is going to be to project the requirements from JAMA into that SysML2 representation with that. So, and then from there, if there are behaviors or architectural elements, we'll be able to embed those as well. So that's kind of a very high level peek at the coming roadmap.
Chris, I have a question about this last part of moving from JAMA into SysML.
Yes.
Will this interface from JAMA to SysML also be open source and available by OpenMBEE?
Yeah, definitely. Yeah, anything we can do that doesn't have anything to do with the project specifically, we plan to do in open source for sure.
Okay, great. And do you have an idea how you are going to go about creating the RDF in that interface? Are you going to be using like a model to text, or are you gonna use the API of OWL somehow?
No, that we'll have to talk to Doris and Jason about their plans for that.
Okay, sounds good.
Yeah. I think it's still a pretty open topic, and I think we want to solicit from the community too. I mean, I think what's nice about how all of this work turned out, both with the SysML2 ontology and with the Flexo work, is there's always been kind of a seemingly disparate set of communities around ontology modeling and SysML systems modeling. And I think this platform and these two bodies of work actually show how these communities can come together. So in the spirit of that, I think that would be a good place for that discussion to take place, as there'll be a lot of future cases as well, I think, where we'll want to first decide, does it make sense to project something like this into SysML or its own native ontology? And second of all, how should that work be done in either case? So, or even if OSLC is the more correct way to represent something, but in the Flexo platform, under the hood, it'll all be ontologies, all queryable across versions and projects and stuff like that. So
this is the beauty
it can appear
of it,
as the
that,
piece you care about, or it can appear as the whole thing. So
exactly, it will become very flexible thanks to the ontological representation. You could either go with a SysML v2 ontology or a native like JAMA requirements ontology or something like that. Yeah.
Right. And personally, since it's popular these days to be opinionated, I've never personally been of the opinion that SysML makes sense as a general purpose integration language. So I know there are some schools of thought that seek to capture everything in SysML, including having that be the intermediate transformation language. But I think what we'll find in this is that only makes sense in certain cases, and then other cases that makes more sense to use something that's more flexible. So, and the choice of Flexo in the name actually comes from Futurama robots, so representing version F of the architecture. So it was unintentionally related, but for those who are Futurama fans, you would have noticed that probably. So
Very cool. Thank you very much, Chris.